video about the catch memory assignment. We talk about mapping functions and replacement algorithms. My name is Deborah Atala. So to start off, we have the mapping functions. And for the mapping functions, we are going to look at three techniques that are used. And since there are fewer catch lines than main memory blocks, an algorithm is needed for mapping main memory blocks into catch lines, and the choice of the mapping function dictates how the catch is organized. So three techniques are used, like I've said. So let us look at direct mapping. The direct mapping technique is simple and inexpensive to implement. For direct mapping, each block of main memory is mapped into only one possible catch line. And when a block is actually read into its assigned line, it is necessary to tag that data to distinguish it from other blocks that can fit into that line. The disadvantage of direct mapping is that there is a fixed catch location for any given block. Thus, if a program happens to reference words repeatedly from two different blocks that map into the same catch line, then the blocks will continually be swapped in the catch, and the hit ratio will be low. So there could be confusion. Then for associative mapping, it permits each main memory block to be loaded into any of the catch lines. The catch logic interprets a memory address simply as a tag and a word field. The tag field uniquely identifies a block of main memory, and to determine whether a block is in catch, the catch control logic must simultaneously examine every line is tagged for a match. And for associative mapping, there is flexibility as to which block to replace when a new block is read into the catch. And the disadvantage is that there is complex circuitry required to examine the tags of all the catch lines in parallel. Then we look at set associative mapping. For set associative mapping, it is a compromise that exhibits the strength of both the direct and associative approaches while reducing their disadvantage. Compromise will mean that it strikes a balance between direct and associative mapping, while also reducing their disadvantages, as we have seen. For set associative mapping, the catch consists of a number of sets, each of which consists of a number of lines. And for set associative mapping, each word maps into all the catch lines in a specific set. So we have set 1, set 2. So the word in the main memory block will map into the entire set 1 or the entire set 2. Then the catch control logic interprets a memory address as a tag with 9 bits, a set with 13 bits, and a word with 2 bits. Then moving on to the replacement algorithms. We see that once the catch has been filled and a new block is brought into the catch, then one of the existing blocks must be replaced. And the replacement algorithms show us how to locate the block that will get replaced in the catch. First of all, we have least recently used as one of the algorithms. For least recently used, the block in the set that has been in the catch longest with no reference to it is replaced. Then the mechanism used maintains a separate list of indexes to all the lines in the catch, and when a line is referenced, it moves to the front of the list. For replacement, the line at the back of the list is used. So therefore, when a new block or word is brought into the catch, the mechanism used refers to the back of the list, and that is the space that is used. Second, we have first in, first out. For first in, first out, the block in the set that has been in the catch longest is replaced. That could mean that the block that appeared first that was put there first means it has been there for a longer time. Therefore, it is what is replaced with a new word or a new block. Then for least frequently used, that is the third algorithm. The block in the set that has experienced the fewest references is replaced. Least frequently used could be implemented by associating a counter with each line to count the number of times. Probably to count the number of times each block gets referenced or is referred to. Then the fourth algorithm is a technique that's known based on usage, and it picks a line at random from among the candidate lines. That is it. References. I referred to Computer Organization and Architecture, the 10th edition by William Stallings. Thank you.